In this video, we will be looking at how to make comparisons between different types of variables with different cases and different units through a process called standardizing values. As an example, let's say you are a part of a committee in charge of selecting the most valuable basketball player in a league. You know that your vote should be based on each player's points per game, rebounds per game, and assists per game. Since these categories are entirely different and the players are on different teams with different experiences, we can't just add the performance in each category to decide who is the most valuable player. Let's start by comparing the points per game for both players. Steve is on Team A and Charles is on Team B. For Team A, the average points per game is 16. The standard deviation is 4.3 and Steve scored 26 points per game. For Team B, the average points per game is 14, the standard deviation is 3.8, and Charles scored 25 points per game. Which player did better in terms of points per game? While we might be tempted to say Steve, since he has the higher number of points per game, there is more to consider. Which player is better, also considering the team's performance? To make a fair comparison for each player, we calculate a value called the z-score. The z-score tells us the number of standard deviations a value is away from the mean. To calculate the z-score, we subtract the mean of the sample from each person's points per game, then divide by the standard deviation of the sample. To find Steve's z-score, we take his points per game, 26, subtract his team's average, 16, and divide by the team's standard deviation, 4.3. We get that Steve's z-score is 2.33. To find Charles' z-score, we take his points per game, 25, subtract his team's average, 14, and divide by the team's standard deviation, 3.8. We get 2.89. So, even though Steve scored 1 point higher than Charles, Steve's z-score is less than Charles' z-score. This tells us that in comparison to their teams, Charles performed better when considering points per game. To decide which basketball player should get the most valuable player award, we need the z-scores for points per game, rebounds per game, and assists per game. We used the information provided earlier to find the z-scores for points per game. Let's say we also calculated z-scores for rebounds and assists and found these values. Since the values are standardized, we can add them up to get a measure of Steve's overall performance. Steve's combined z-score is 7.86. We do the same for Charles, finding that his combined z-score is 8.29. Since Charles has the higher combined z-score, he performed better overall, so he would be my vote for the MVP. Here's a summary of what we've learned. A z-score is the number of standard deviations a value is away from the mean. Finding z-scores is also known as standardizing or values. Standardizing values allow us to compare different types of variables with different cases and different units. To find the z-score, we use the formula z equals the value minus the mean of the sample over the standard deviation of the sample.